Hello everyone, and welcome to part 3 of my Docker webinar series for Cloud Academy. Sorry about that. This is a wrap-up session, so what we will be doing is talking about some of the things that have come up in the previous 2 sessions and focus on some of the jumping off points to consider if you are interested, say, in adopting Docker, curious about Docker, or already actively using Docker for development or production. So before we get started, I have a quick poll for all of you to get a feel for the audience, and based off this can tailor some of the answers and some of the discussion. Okay, so thank you for answering the poll, and now let's move on. So what we're going to do is cover some of the recurring questions that came up from the past sessions. So given that a lot of you have attended the past sessions, maybe you have seen the Q&As on the Cloud Academy community forum where I've answered all of the questions, and there were some recurring themes from part 1 and part 2. So as a way to capstone the series and to recap the ideas of the past sessions, I'm going to answer some of the recurring questions from those sessions, and then we'll devote all of the remaining time to the questions that you have. So if your question is not hasn't been answered before, please save it till the end, and hopefully we can get to those questions. So for those of you who don't know me, my name is Adam Hawkins, and I lead the Site Reliability Engineering team at SaltSite. And right now we manage roughly 350 containers in our production environment. And we've been using Docker for just over 2 years. I've also created the Introduction to Docker course for Cloud Academy. And if you want to find out more about me or also more information about Docker automation, things like that, you can check out, you can find me on Twitter and check the /deploy blog. You can also find some links to other presentations and things like that on the /deploy blog itself. So let's get into summarizing the past 2 sessions. So this might be a simple question for some of you, but I think it's important to iterate what Docker actually is. So the first thing is actually an application agnostic container runtime. So it's a containerization technology that's built on top of functionality in the Linux kernel that allows users to run processes isolated from the other processes on the system, and it also allows us to do things like compute quotas for CPU, memory, network, other things like that, so that these processes can, play nice with all the other processes running on the system without really having to worry about conflicts and things like that. So the other thing to understand is that these containers are actually running on the same kernel. Now, what a common misunderstanding or a common term that is thrown out when talking about Docker and comparing it to other things is that it's actually different than virtualization. People say that Docker is lightweight virtualization, and that's not necessarily true. They focus on different sort of things. Docker containers and all of the containerization technologies built in Linux kernel are significantly different than virtualization because they focus on running multiple processes on the same kernel instead of typical virtualization, or like say a whole VM, which focuses on virtualizing the entire CPU, the whole kernel, the whole user space, the whole user land around that thing. So when we talk about Docker and containers, what we're able to do is have more effective resource utilization on the machine running our containers, where we can actually say share the CPU or share the memory. Whereas if we had a VM, we would need to have much more compute resources to dedicate fully to those virtual machines. So one of the other recurring themes is what can I actually do with this? And this was sort of covered in part 1, which is more focused on introducing Docker as a concept, talking about the ideas and some of the use cases. So I think one of the best use cases for one of the best applications of container technology is actually creating portable development environments. And I think as what we see happening in the industry now is that there is a more proliferation of different technologies. You might be in a team that's using 1, 2, 3, 4, maybe even 5 different tech stacks. And that can be a problem as you move between different projects, and maybe you can't, maybe you don't know how to say install Scala from one team, another team is using Node, and it sort of goes on. But this also allows us, or allows you or your team to create development environments that may work agnostic of the actual host environment themselves. So maybe some people in your team are using Windows. Some people are running, say, Arch Linux. Some people use Debian, Fedora, so on and so forth. But given that we have these things if we build environments on top of Docker, we have more inherent portability than if we didn't. So the other aspect of the webinar series is focusing around production. And the development side of Docker's, or the use cases in the development phase are very important. But ultimately, the things that we develop as engineers have to go to a production environment. They have to be delivered to somewhere where somebody can derive value from this work. And for teams and software, a lot of software companies these days are building out larger distributed systems using different languages, different things like that, as different components of the system had different technical requirements, maybe see different load, different things like that. And as you can imagine, it would be quite hard for, say, a team to manage n number of different tech stacks. Ask yourself how familiar are you with, say, building a stack to run, say, a Ruby application, maybe a Java application, a Python application. But if we standardize on containers, then we can build our infrastructure around containers, and it's no longer important what is actually inside those images, given that we can run them as containers. So one other area where Docker and containers themselves are useful is actually containerizing your build system. Build systems are sort of inherently stateful in that they need to know a lot about the project. They may also, say, touch the machine, need to install packages. That also requires that the process running has certain administrative privileges, like sudo access. It's going to kind of muck with a lot of stuff. And that may become more complicated as more and more projects come into the build system. And of course, we want to keep every single build pristine so that one build does not affect the next one. So it's possible to, say, run every single build inside of one Docker container and then just throw away the container at the end of every build. So if you are dealing with applications that require a lot of config, you can just throw them into a container where they can have root, do whatever they want, and then just throw the container away. Now, this was also one use case that sort of came across internally in my work, which was delivering command line tools. So internally, we have built a lot of different CLIs. Most of these things are actually written in Ruby. And if any of you have worked with Ruby, it's quite a pain to get someone to install and maintain a functioning Ruby environment, especially once that Once the application has, say, C extensions, which is going to compile things, and then you do have other native packages installed on the actual system itself, and of course those vary by, say, how you set it up on OS X and Linux and so on and so forth. And for somebody who just wants to, say, run your application or run your tool, they don't necessarily want to know how to install the whole environment. So what you can do is package up your tool as a Docker image, and then create some wrapper script that maybe does the whole Docker run thing and associate it with the tag. And at the end of the day, what this comes out is actually a very effective way to deliver software to end users. When you combine that with different tags, you also have a built-in sort of versioning system, so you can say I want to be on version 1, version 1.2, or however you want to tag your images. So it's been quite an effective use case of container technologies. So this last point is really a combination of some of the other ones, but really where we see the largest adoption of Docker and specifically containers is larger scale distributed systems. And these days, distributed systems tend to imply also microservices, which also tend to imply some sort of more polyglot things. And that, of course, that scale varies by team or by technical situation. But what we really see happening is containers make it easy to build larger systems which are decomposed into smaller individual components. And Docker or any sort of container technology is specific, is really suited to those sort of use cases because you can standardize your infrastructure and allow the teams to sort of build out the application in the way that they see fit. So in the part 1, we talked about how to use Docker in development. And I think that this area is certainly the most well-traveled, the most well-traveled, and sort of where most of the solved problems are. Most of the people who come to Docker initially start out using Docker for their development environment or some other thing that is certainly pre-production. So the best way to get started with Docker in development and to build an ongoing development process around Docker is to just use Docker Compose. So Docker Compose is a tool that allows you to manage, or not manage, but to model your application with a configuration file. And what this does is allow you to describe all of the different containers that make up an application, their configuration, like their networking, all those sort of things like that. So the kind of classic example is that you can have one container that's running your web server and another container that's running your database. Be that, say a Mongo database, NoSQL, it could be RDMS, MySQL, PostgreSQL, or even like you could have Sidecar for your, say, a Redis or something like that. Then you can just add more and more things into that Docker Compose file. And the Docker Compose tool is going to give you all the sort of handy things that you need to, say, just build all your images, start all your containers, and given that you can also define the dependency graph between, say, your web server and your database, when you tell Docker Compose to start your application, it will traverse that graph and then bring everything up in the correct order. So all in all, Docker Compose is pretty much the best way to handle the development stage of a Docker-based application. And also, if you use Docker Compose in the development phase, you can potentially integrate with the first-party Docker Inc. tools to, say, take your Docker application and deploy it to some production-ready infrastructure. Now, if you're not quite ready to make the dive into configuring all sorts of production infrastructure, maybe you just want to have, say, a Docker Swarm cluster or something like that for playing, you can use Docker Machine. So Docker Machine is a tool, it's a first-party tool written by Docker Inc. that allows you to create Docker hosts. So a Docker host is a machine running the Docker daemon. So given that Docker fits into the client and server model, You can have your Docker client running on your machine and the Docker host or the Docker daemon running, say, on EC2 or Google Compute Engine, or even on Azure, Rackspace, or anything like that, or like what we see in the real, in most development environments inside some virtual machine or other virtualization technology. This is especially applicable to Windows and OS X. So Docker Machine is a great way to get some sort of exposure to setting up, like remote Docker daemons, and you can play around with these things. So I do encourage you to look at Docker Machine, get some experience with some of these other things, and also it's a very easy way to set up a Swarm cluster if you want to play with that in a functioning thing that may not be production ready. Now, one of the real places where I think that containers and Docker shine in the development stage is that it makes it really, really easy to change the different versions of the stack that you're using. So in my example here, you can use Docker to test different databases. So let's say that you're running Mongo 2.8 and you're working on some code, or you have to upgrade your code to support a newer version of a database. Now, this might be problematic in certain scenarios, because let's say that you're doing the development directly on your host system. Now at this point, maybe your package manager or your setup doesn't actually allow you to have two independent versions of those packages installed. But with Docker, you can just say, I want to use this tag. So you can also do that with your base images. So let's say that you're running on Ruby 2.2 and then Ruby 2.3 came out. Change your base image, build your image, run your tests. Very, very easy to just try out the different versions of the software. Now, part 2 focused on Docker in production. Now, I will admit to you that I'm a bit biased in that this is really where I'm focused right now, and I think where the industry and a lot of the engineering effort and sort of the energy is, because, as I mentioned before, I think that Docker in the development phases generally a solved problem. And now what we see is a move and a push into what can we do in a production environment? How can we take these systems into production? How can we scale them? How can we manage them at a larger scale? So the way that we can use Docker in production is pretty much the same way that we would approach running, say, a non-containerized system, with a little bit of different quirks for this. So really what we have is a few different options. So one is going for some hosted service. I mentioned hyper.sh here just as an example because they have come on the scene. They're doing some pretty interesting stuff where they actually run the containers. You could also use something like Heroku, which has Docker support. You could, say, roll your own infrastructure. Maybe some of you have experience building golden images. So you can, say, use a tool like Packer to produce a base image, say an AMI, that you can give it then a Docker image, and then you can throw that golden image into an auto-scaling group, put it behind a load balancer, and you get a pretty robust system right away. Or you can opt for a more complex orchestration-based solution. And of course, which one of these tools you choose really depends on your requirements. And if you want to know more about these different tools, then I suggest you go watch the video recording for part 2, where a lot of these options are covered in depth. So once you've actually chosen your deployment target, then the next thing to do is set up your health checks. So a few things have changed or have kind of come onto the scene in the recent past. These newer versions of Docker actually have a health check argument in the Docker file, which is integrated with the Docker daemon. Now, what this will do is execute this command, whatever you configure, say, for example, using curl to make an HTTP request to the process running inside the container. then you can test if that's up or down, and the Docker daemon can monitor those things to potentially kill the containers and start them again. And you can also use this for zero downtime deploys, ruling updates, things like that. Or you can do something in the orchestration tool itself. It sort of depends on what your deployment target is, but the first thing that you want to do is choose what you want to deploy to, and then set some basic way for that tool or that infrastructure to monitor the but the health or the readiness of the containers that are running. Excuse me. So then what we want to do is integrate your target with your metric collection tools. So most of these, pretty much any type of metric tool that you could think of, like New Relic, Datadog, like CollectD, all of these sort of things are going to have some integration with at least the Docker daemon or even the orchestration tool. So for example, if you are using something like Kubernetes, you can install an agent, and then that can give you some metrics about your entire Kubernetes cluster or about the specific containers running on a particular node, things like that. But you want to make sure that regardless of whatever you use, you have those metrics about your containers at the host level. So all of the things that may affect the actual Docker daemon and the resources that the kernel can allocate to the containers, and then the metrics about what the container sees. So you want to see your, say, host CPU usage, your host memory, how much is available, and then what the container sees, because we have different quotas at play and different things going on. So you want to make sure that the metric collection tool that you use will give you both of those sets of metrics. Then, depending on how aggressive you like to be, but I suggest that you connect your CI system to trigger deployments. And this might not be to production, this could be to any of your, say, pre-production environments like your staging environment or QA environment, whatever you want to call it, but make sure that you can trigger some sort of deployment to your infrastructure via some API or CLI. This might be, if you're using Docker Compose, maybe you do, say, a Docker Compose up, or maybe you do a Docker push, you push your image and it's listening to something like that. Or if you're using Kubernetes, maybe you make a call to the update deployment API and change the tag of the image that's running. So regardless of whatever thing that you choose, you want to figure out a way to connect your CI system to that infrastructure so you can trigger deployments. So given that we are talking about containers here, usually talking about some level of automation also. So we should be able to have at least the continuous delivery aspect, not necessarily continuous deployment, but you can make that call. So this is one question that came up a lot during the past two sessions, is like, really, what are the pros and cons? So of, say, using Docker or adopting this technology. And the answer to this question, I think, maybe changes every couple of months. So I'll give you the best answers that I can see at this current point in time. So for me, I think the biggest pro is that this offers flexibility to application developers. And this pro you may see this as a pro depending on what role you play in your organization. So given that I spend a lot of my time developing infrastructure and automation for other engineers to actually deploy their stuff to, for me and for many others, it's a really big pro that the developers can choose whatever tech stack that they want, and that at the infrastructure level need not actually care about this. And what this has allowed, in my experience, is allowed the existing engineers to choose whatever tech stack or language or whatever was best for the job, and B, when new engineers joined the company who did not have experience with any of the existing languages or stacks in production, they were able to make a decision to use something that they were more familiar with. So this is something that certainly pay dividends at some point. So this one is touted out quite commonly, which is well, depending on who you talk to, they may say you can have one-to-one parity with development and production. But in my experience, that actually never really happens. There's always very subtle differences between a development environment and a production environment, and then any number of non-production environments. So I want to make the point here that by using Docker, you'll be able to increase the development and production parity depending on what your particular process looks like and the requirements that you have. At a minimum, if you're using the same images in development and production, you'll have a higher level of parity. Now, say for example, if you are developing locally with Docker and just running locally on your Docker host and then deploying to, say, Kubernetes, sure, you're using the same images, but the actual structure, the topology of those environments is not necessarily the same. So regardless, you will be able to increase the parity between the development, production, and other sort of non-production environments. Yeah, so as I mentioned before, this actually gives a platform to actually standardize the infrastructure. And this actually really provides a lot of benefits, really, in that, say, if you decide that, say, all of the images or all of the containers should produce log output to standard out or standard error, then if everything is running as a Docker container, you can integrate your Docker daemon with any different number, say, of log drivers, like, say, syslog or journald or fluentd, any of these other different backends. And you can standardize the metric collection from these containers. It gives you really a lot of different things because you have a nice clear boundary around what the actual artifact is. It's not necessarily code anymore, it's an image. And that image can run a process. So this really empowers the operational infrastructure staff to standardize the infrastructure and improve the functionality or the features that are actually offered to the people who are running their containers on that infrastructure. So, of course, with anything in engineering, there's all sorts of, nothing is 100% perfect. I don't think Docker is either. So what I have seen in the past couple of months, maybe say the past 6 months or so, is that things are actually changing very rapidly. And Docker Inc. is pretty keen on making big changes to kind of making just big changes in general. Like what we see happening is, say, a big shift in Docker Inc.'s positioning from more of developer tools, like say Docker Compose and Docker Machine, but in the past year or so, they're making a big push, and even more recently into the orchestration space with Docker, with Swarm mode, which is built into Docker, I think 1.12. And then what they're doing is introducing more configuration files, concepts of like services and tasks, kind of restructuring things to fit an orchestration-based world where you have multiple containers, more complex applications instead of a single container. So, and since Docker Inc. controls really the Docker project, things can happen quite rapidly, and the ecosystem has certainly matured a lot in the past 2 years, but it is still changing and evolving quite rapidly. So the next one is that regardless of any pros or benefits that we see from adopting this technology, it's certainly going to increase complexity of the overall system, because now what this requires is that everybody, or all of the different engineers involved in operating the system now must understand the system from two different perspectives. There is the process running in the container, and then there is the Docker daemon, which is managing the container. Things like networking behave differently outside the container and inside the container. And now you also have to ask, say, is the problem inside the container? Is it outside the container? It's just another layer that you have to be aware of and know what can go on in and outside that layer. Now, personally, I think that this one is the most important because Docker is the first thing to achieve a critical mass in the container space, and Docker is really the first wave. So I think that in the next maybe 3, 4, 5 years, we probably won't see just Docker, but there will be much more other container technologies. And if, as an organization or as teams, if you choose to adopt or get into Docker now, what you really do is get into containers, which changes the way that we approach, say, software engineering and infrastructure. And I know that the future is containerized. So by adopting Docker now, you get prepared for a containerized future. So I do get this question quite often. This actually was derived from a presentation that I put together about using Docker, or experience from building and using Docker for 2 years at Saltside. So kind of a summarization of best practices that I have observed. So if you're not using Docker right now, the best thing to do is start with a proof of concept in a development environment. This is the easiest way to get started and an easiest way to quickly vet the technology and see how it works and get a feel for it. So the next one is really just use Docker Compose as much as possible. So when we started out, we were doing a lot of this sort of orchestration, like this sort of configuration, linking, networking all manually, and eventually just sort of fell over in a way that it wasn't really scalable. And in hindsight, it would have made more sense to use Docker Compose as much as possible. So if you're not using Docker right now and you want to get started, start with the POC and use Docker Compose. That will also give you options in the production deployment space. So this one is my own personal opinion, and I think that right now the easiest way to get a production ready infrastructure is to just use Google Container Engine, which is a hosted Kubernetes. And if you're not familiar with Kubernetes, I suggest you check out the part 2, where we talk about these orchestration tools. So right now, the sort of space is that a lot of the hosted services are not necessarily as evolved. Like, for example, there's plenty of things like Heroku for other applications, but the space around Docker is not yet so evolved. I think that right now, Google Container Engine is the best and fastest and most easiest way to get to a point where you can confidently deploy container native applications to a production environment. Well, one other thing that we learned the hard way was that it's easier and more beneficial for everyone if you just use the official images as much as possible. I think that ultimately, in most cases, it's a waste of time to create your own base images because they usually lag behind. They don't have some of the features built into the new official images, like the security scanning, things like this. So ultimately, in terms of the cost trade-off, like the cost-benefit analysis that I see, it's not really worth it to spend time building a bunch of internal images. One other one that came up is using one Docker file per project. So if you're using Docker containers a lot in your different projects, maybe you have different, like say one application that maybe uses two different processes, say maybe a web server and a background job processing queue. It might be tempting to create one Docker image for the web server and another Docker image for the job processor, but in my experience, it becomes harder to maintain as now you have different base images, more images at play. Ultimately, it's easier to have one Docker file which contains all of the different code required to start any of the processes as part of that particular project. And you have to ruthlessly stick to the 12-factor app principles, like the configuration via environment variables, logging to standard out, standard error. So if you're not familiar with the 12-factor app principles, I suggest you do Google those things because they will make all of the applications that you develop on top of Docker or any other container technology much, much easier to maintain and deploy to any number of environments. And most importantly is to actually take containers and bake them into your process at all of the stages for the biggest benefit. Like, you cannot necessarily take an existing project, throw a Docker file, a Docker file in there, have it go through the very whatever the existing sort of CI process is, and then at the very end do a Docker build and then push and then just hand that image off to someone else. You'll see some benefit from that, but you're not going to get all the benefits of going truly container native until you bake containers and the thinking that containers promote into all stages of your development process. So this is the last little bit that I'm going to talk about, which is some of the future and some of the other things that I have not yet talked about in any of the other sessions before having time to your questions, and I'll keep this section short. So the future is really, I cannot stress this enough, it's seriously just all about orchestration and all of the problems around orchestration, building the tools on top of the orchestration frameworks, and handling all the UX, sort of getting these host services like Google Container Engine I mentioned, but really it's all about orchestration. It's putting the applications in production and having software that allows like sysadmins, operational staff, all the different sort of engineering roles to build and scale out a system. So it's orchestration, orchestration, orchestration. Now, one of the things that came up in part 2 was talking about the different deployment options. And I had suggested that there was a Docker data center, but based off of my evaluation, there were some real red flags for me on adopting that for production. That was like version 1 point something. And when I raised these issues to the Docker support team, they said that they would be fixed in Docker Data Center version 2. So now what we have is hopefully a more production-ready system, or a production-ready first-party orchestration system from Docker Inc. If you want a swarm mode cluster that you can just have your existing Docker Compose application to, and then deploy it to a cluster, then Docker Data Center might be something to check into. And specifically version 2, which has some very important fixes. The other thing that came up, or actually didn't come up in any of the other sessions, was the log drivers. So initially, we sort of focus on a lot of the things around starting containers and just getting something running. But there's a lot of stuff that comes up after you have it running. So when it's running and then it crashes, you need to find some logs. Or when it's running and you want to, say, correlate the logs between a container running on one Docker host and a container running on a different Docker host, then you need to have some sort of centralized logging. And I touched on this just a little bit, but if you haven't looked into this yet and you're looking at sort of the larger operational characteristics of a system built on top of Docker, then you should look at some of the integrations that the Docker daemon provides with external systems, like FluentD, for example. So do check that out. So given that this point is kind of into the future, and I touched on it earlier, that I think if you project far enough forward into the future, what we'll see is a higher prevalence of alternate container runtimes. Right now, Docker is by far the biggest player in the container space, but that doesn't negate the fact that there are alternate runtimes out there right now. And if you look at the different orchestration tools like Kubernetes or Mesos or things like this, they will support the alternate runtimes. And what this does is give all of, say us as engineers, other options, potential to avoid lock-in, things like that. So what I think what will happen is a shift probably away from Docker at some point in the future, given that Docker is sort of the first wave. What we'll see is a proliferation of these alternate container runtimes, which will have different characteristics, maybe different features, remains to be seen, and the orchestration tools or whatever sort of targets we have or the technologies that we use to run our containers will support different features depending on the actual runtime for the containers. So pay attention to the alternate runtimes and just keep this in the back of your head. So that was all I had for the wrap of part 1 and part 2 and the things to consider for the future. Right now we have maybe 15, 20 minutes or so for questions. So if you have any questions, please type them into the chat and I will pick the best ones and do my best to answer them. Okay, so let me pull up the chat here. Okay, so one question, how is Docker different from a normal virtual machine? So this was also covered in part 1, so I will do my best to reiterate what I had covered in part 1, and if you don't get a good enough answer, you can rewatch that session. But the key difference is that Docker containers, every Docker container shares the same kernel as the host system, whereas a normal virtual machine will have a separate kernel from the host system. So let's say that you have your machine and you're running 5 different Docker containers. Now you have one kernel that's running 5 different processes. But if you say have 5 virtual machines, and you have one hypervisor that's running 5 different kernels with their whole set of resources and things like that. So it's covered in part 1, also in the QA for part 1 on the community forum, and there's a lot of good blog posts and things like that. So if you actually just go to docker.com, you will find an illustration, if you're a visual person, that might answer this question better than I could just by speaking about it. All right, next question. Should I use Vagrant or Docker for creating an isolated environment? So this is a bit of a bigger question, but I'll do my best to answer it. So first of all, when we talk about Vagrant, Vagrant is a tool for managing virtual machines. And these virtual machines can be a VirtualBox or VMware or AWS, things like that. So I think the answer to this question is depends on what you want to do with Docker versus what you would want from a VM. So in my thinking, if you want to create an isolated environment, what are you going to be doing inside that environment? Are you going to be sitting in the shell? Do you want to start multiple processes? Those processes might actually even be Docker containers. So, for example, you might create a virtual machine using Vagrant that installs Docker and all the other things that you need, like say all of the commands you need to maybe build software or do something like that, versus if you are going to use Docker containers to kind of create the same thing, then I think that that's probably not the right way to go, because you don't necessarily want to be sitting in a container for, say, an interactive thing. And the other thing to remember is that Docker containers are inherently ephemeral unless you have a shared volume to share state between things like that. Whereas a virtual machine is going to be inherently stateful. So everything you do inside that VM will be persisted, whereas the things you do inside a container, unless you've done something explicitly to give you a means to share state, they are not going to be shared. So depending on what you want to achieve, I'd say based on that question, you're probably better suited to go for Vagrant in a virtual machine instead of trying to do the same thing with Docker containers. Okay, next question. What is the difference between CMD and entry point in a Docker file? This is a good question, and to understand the answer to this, first we have to talk just a little bit about shells. So CMD is the default command that is executed if none is given. So for example, if I say docker run Ubuntu, maybe the default command is ls, and it runs ls, versus if I say docker run Ubuntu bash, then it starts bash. Entry point is a thing that's prepended to all those commands. So for example, let's say that you are writing a program that, or you have a Docker image that is intended only, and I mean only, to invoke one specific command. Let's call that foo. Now let's say that this foo command has two different subcommands, bar and baz. So if I sent my entry point to foo, then all of the things I specify in the command will be invoked via foo. So if I say docker run, I also call my image foo, I can say docker run foo bar. What that will invoke inside the image is through the main command foo and then the subcommand bar. So the official images are also demonstrate a good use of entry point. And this is specifically in, I think, the Postgres and MySQL containers, in that they have an entry point, which is a shell script that does some environment variable things, some setting, running some other commands before actually running the main command to say start the database. So entry point is the command that actually kicks off the whole process. You can use this to wrap existing commands or change the sort of, for lack of a better term, the entry point into a container. So the difference is CMD is about defaults and may or may not be applied, but entry point is always applied, and entry point can be used to wrap or change the commands that will be executed, and CMD is really just about a default command. I think we have time for one more question. Question is how to upgrade a Docker container after its image has changed. So I will do my best to interpret this question, and from my understanding, I understand it as there is a container that's running. Let's say that it's running image, just call it image foo, and the tag is say version 1. And now I have a new image called foo, and I tag it v2. And now I want to change the image for that container. And the only way to do this is to start a new container with the new image. You cannot necessarily change the image associated with a running container. So if you have a new image, what you need to do is start a new container, or start a new container from that image. This is where the tooling around deploys becomes more important, because ideally what you want to have is you have one container that's running the old image, and then you want to start up a new container running the new image. When that container with the new image is online, then you want to terminate the old container. Maybe you have a load balancer in between, you have some sort of a blue-green deploy, but ultimately the answer how to upgrade a Docker container after its image is changed is to start a new container. So I think that will do it for the QA in this section. So I want to thank you all for attending this webinar, especially those of you who attended part 1 and part 2. And I also suggest that you head over to the Cloud Academy Community Forum to find the Q&A for part 1 and part 2, and also the QA for this session will also be posted on the Cloud Academy Community Forum. So once again, everyone, thank you for coming to these sessions. I hope they were beneficial for you in some way. If you have used Docker before, I hope you learned something. If you're curious about Docker, I hope this helped you get some orientation on how you can start using Docker. All in all, I hope that it was educational for you, and thank you all for sharing your time with me, and best of luck out there. So, thank you, everyone. Have a good day.